A code smell is a hint that there might be something not quite right with your code. It doesn't necessarily mean there's a bug, but it does suggest areas where you might improve the design or implementation. Coined by Kent Beck and Martin Fowler, this concept emphasizes that while code should be clean and easy to read, any hint of messiness might indicate deeper issues. In this video, we'll outline 5 of the most commonly occurring code smells, why they may indicate problems and what to do about them. A large class typically has too many responsibilities, leading to complications in understanding and maintaining the code. Essentially, it violates the single responsibility principle, an essential guideline in software development. To address this issue, the class needs to be refactored. One approach is to begin by identifying distinct responsibilities within the class and then splitting these into separate classes. Another method is to use extract class refactoring to move parts of the code to new classes, thus simplifying the original class. Let's consider a simple example. Suppose you have a class called Order Processor that handles customer details, payment processing, and order tracking. This class can be refactored by creating separate classes for handling customer details and payment processing, leaving the Order Processor class with a single responsibility of order tracking. By doing so, each class now has one clear purpose, which enhances the code's maintainability and scalability. The long method code smell occurs when a method in your code has grown too lengthy, making it challenging to understand and modify. Such methods often try to do too much, combining multiple functionalities that could be separated. The best way to address a long method is through extract method refactoring. This involves breaking the method into smaller, more manageable pieces, each doing a single task. For instance, consider a method in a shopping cart system that calculates the total price, applies discounts, and updates inventory levels. By refactoring, you could create separate methods for each task, one to calculate the total price, another to apply discounts, and a third to update the inventory. This not only simplifies the code but also improves its testability and reusability. A primitive obsession occurs when simple data types are overused instead of small objects for specific tasks. This can lead to code that is less flexible and more difficult to understand and maintain. The remedy is to replace primitives with class objects that better represent the concept and behavior. For example, instead of representing a currency with just a double for amount, create a currency class that encapsulates both the amount and the currency type. By using this approach, you enhance the expressiveness of your code and improve error checking, as operations inappropriate for certain data types can be avoided by design. Feature envy is when a method shows too much interest in the data of another class, accessing its fields more than its own. This can lead to a design where classes are overly coupled and changes in one class might adversely affect the others. To correct feature envy, the move method refactoring technique is typically used. This involves shifting the envious method to the class whose data it is most interested in. For example, if a payment class has a method that calculates discounts based on customer history, but it frequently accesses methods from a customer class to get the necessary data, it might be more appropriate to move this discount calculation method to the customer class. This change aligns the method with the data it primarily operates on, improving the cohesion of your classes. The duplicated code smell is one of the most common yet problematic issues in software development. Duplicated code occurs when identical or very similar code exists in more than one location. This redundancy can lead to errors and inconsistencies because changes made in one place must be duplicated in others, often leading to mistakes or omissions. To address this, extract method and pull-up method are useful refactoring techniques. For example, if two classes have the same method for calculating a discount, you can extract this method into a common superclass that both classes inherit from. This not only eliminates redundancy but also simplifies future modifications by centralizing common functionality. By eliminating duplicated code, you enhance the maintainability and consistency of your codebase, making it easier to manage and evolve. In looking at the top 5 code smells and their remedies, we've only scratched the surface. There are many more examples and types of code smells that we haven't covered. To deepen your understanding of code smells and how to address them effectively, you should explore further resources and literature on the subject. Keeping your code clean is not just about fixing bugs. It's about maintaining a healthy, scalable software environment. Stay curious and keep learning to improve your skills in identifying and resolving code smells.